4, a factory makes boxes like this of a square. They use a square and they cut the 4 corners, fold it, and they get a square. No, they get a box. And we should show that the volume of the box is as it says down here, but remember the volume. So if you cut it out, like we've seen in class, we get a box like this, right? And the volume of such a box is length times width times height, and the length here will be this. Right, and remember this is A, says the exercise here, and have it cut out X and X on each side. So this will be A minus 2X. The width is this, which is also A minus 2X. And the height, when I fold this up here, fold this in here, this will be the height, which is then X. So then the volume will be A minus 2X times A minus 2X, length times width times height, which means that we can, of course, then this is a function of X, and we get A minus 2X squared times X. And we could, of course, multiply here with a binomial formula, but we'll just keep it like this here. So this is the volume as a function of X. And then the question is here, how much do we need to cut out? Should we cut out 1/6 of the square here? Right. Take, if you have the side A, should we cut out 1/6 on each side? That was Per believes. Should we cut out 1/4 on each side and then make a box, or will this depend on what A is? Yeah. Do calculations and find out who is right. Let's do it by hand or with cos. Let's do it by cos. It takes a lot of time with hand, so if you want a challenge, you can try and do this by hand, but I will show it on cos here. And then I need to define the function. And when we have A and B and so on in a function, we have to use cos, not graph. Let's see here. V of x is equals to A minus 2x square times x. And we don't get a graph because of this A here. And I want to maximize this, so I need to find the maximum point. I can try this external thing. And we will see it doesn't work. That's because it is A here. But another way of finding it is, of course, putting a derivative equals to 0. This is an equation, so I press this. And I get two answers. X is equal to 1/2 of A and 1/6 of A. And one of this is the maximum point. This is not the maximum point. You can try if you want. Then I check the mood when X is 1/2A. And we get the positive answer. Remember, A is the side of the square, so A is positive. So this will be positive, and then the graph here, V is smiling. So this is the minimum point, and I want the maximum point. Let's see if the other one is a maximum point. Check the mood, the graph when X is 1/6 times A, and I see it's negative, so this is the maximum point. So the thing is, the volume will be maximized if X, which is what we cut out in each corner, is 1/6 of the length of the square. So that means that Per is correct here. Per believes this, and that is correct. 1/6 of A. So that is correct. So that's the answer on the task. We could, of course, also find the volume of this thing by putting the x coordinate into the function, and then we get this answer. If you have a square with sides A, the volume would be 2/27 times A to the power of 3. So that was exercise